Hello, Algebra 2. Here we are with Unit 1, Lesson 2, solved by graphing and substitution. We've got some fancy words up here that might help you out on the ACT, SAT, or IO assessments. When you're solving a system of equations by graphing and it's consistent, it means it has at least one solution. Inconsistent means no solutions. If you are consistent and have at least one solution, more fun. Independent means you have exactly one solution. Dependent means you have multiple solutions, and in this case, infinite solutions when we're talking about two lines here. Here's our possibilities for graphing two lines. They could cross at one point. They could end up being the same line or overlapping lines and share infinite points in common. Or we could be parallel lines and have no points in common or no solutions. Alright, let's take a look. You might get a really friendly problem when both equations are already in slope-intercept form. Remember from slope-intercept form in previous class that our back number is the y-intercept. That's probably where you are going to start graphing from. It's your starting point. And the number touching x is going to be your slope. And that's going to be our rise over run. So for our first line here, we're going to start at -5 on the y-axis. And our slope is 2. Okay, remember 2 can be rewritten as 2 over 1. 2 divided by 1 is still 2. So we're going to go up 2, out 1. And when we're graphing this, we're always going to go to the right. So up 2 over 1. Up 2 over 1. Up 2 over 1. And we're going to do this a bunch. Because when we're doing this solved by graphing, it's really nice when the lines intercross or intersect at a point that we already have on our line. Get your student ID out for a straight edge. Time for line number 2. -x plus 4. We're going to start at plus 4. 1, 2, 3, 4. And -x is the same as -1 over 1. So we're actually going to go down 1 over 1. And there we see where we're going to cross at. And we'll cross at 1, 2, 3, comma 1. And we're going to put our answer as a coordinate point. Next, over here, again, if I get going too fast on the videos, guys, you are in control. You can push pause, slide it back a little bit, listen to it again, okay? If you need a little bit more time transitioning from problem to problem, you can go ahead and push pause. Sometimes it's not going to give it to you set up so nice. You might have to do a little bit of work. I'm going to slide this over so I have room underneath. So I have room underneath to work. Okay, it's the beginning of the year. Let's show all of our work. We don't want to be making silly mistakes. So let's move those x's over. -3x plus 2. And now we're going to divide everything by 2. And we have y equals -3/2 x plus 1. So we know that's our starting number, plus 1. And our slope is a fraction, -3/2. If we ever have a negative with our fraction, we're going to put that on the top. So we're going down, and that bottom number is always going to be positive and going to the right. So down 3, out 2. Down 1, 2, 3, out 2. Down 1, 2, 3, out 2. And just after I say how we're always going to go to the right, You know, your points don't always intersect on just this half. Sometimes your lines are going to cross over here. So how could we back that up? Instead of down 3 over 2, let's reverse. Let's go backwards 2 and up 3. Backwards 2, up 3. Backwards 2, up 1, 2, 3. Backwards 2, up 1, 2, 3. And there's our line. Okay, and that is a great strategy that a lot of kids will stay with the whole way. Always change it to y equals form. Sometimes we get equations like this one that are a little bit more friendly for a special situation called intercept form, or I call it cover-up method. Okay, we talked about how this is our starting point, the y-intercept. It's on the y-axis, so that was going to be 0, negative 5. So your y-intercept is always at 0, a y number. Your x-intercept is always at an x number, 0. If you remember from geometry, it takes 2 points to make a line. Here's your 2 points. So sometimes when the numbers play nice together, like 1, 2, 10, we can do this little method, a little shortcut method. So if I want the x-intercept, I got to plug 0 in for y. What's 2 times 0? 0. And 0 is nothing, so we can cover it up. It's gone. And now I see my x-intercept, x equals negative 10. Negative 10, 0. Is going to be our x-intercept. Your y-intercept, 0, y. Plug 0 in for the x. It's gone. Negative 2y equals negative 10. What times negative 2 would be negative 10? How about a negative 5? 0, negative 5. Positive 5, Mr. Handke. You've done this 5 times already today. Positive 5. 1, 2, 3, 4, 5. And we can kind of see that we're going to cross right there. It was a good thing we did that backwards point. And we'll cross at negative 1, negative 2, 1, 2, 3, 4. Negative 2, positive 4. Okay, that method works when you don't get fractions and decimals with the cover-ups. If you're going to get fractions and decimals doing that, then that's not good. That makes it tough. Your lines will be off a little bit, and they're going to crisscross at different spots. Next, more fun with graphing. Okay, this one gives it to us in a nice form, slope-intercept form. Negative half x plus 2. Down 1 over 2. Negative 1 half. Down 1, out 2. And we can do a couple backwards ones. Up 1, backwards 2. And there's our top line. Okay, we could do the cover-up method with this one. Our x-intercept is going to be at 4, positive 4. 1, 2, 3, 4, that dot. And our y-intercept is going to be at, divide by 2, is going to be at 2. Look at that. It's the same line. And if they're the same line, all their points are in common, we'll have infinite solutions. Infinite solutions. All right. Over here, we got a nice one to start with. 2/3 x minus 4. So we're going to start off at minus 4. 1, 2, 3, 4. And our slope is up 2, out 3. Up 2, out 3. Okay. I'm usually a fan of more slope dots. but I know this is the other special case, so we're not going to be crossing. Okay, this one, it's not the greatest for cover-up methods, so we should probably solve this out. Subtract that 2x over and divide by a negative 3. Y equals negative 2 over negative 3 is a positive 2/3 x. Negative 3 over negative 3 is going to be a plus 1. So we're starting at positive 1 this time, with a slope of 2/3, which matches the other slope. So you should already be thinking from geometry that these lines are parallel. Okay, and we can see that they're not going to cross. They have the same slope, up 2 over 3, up 2 over 3. Different starting points, so they'll never cross. Parallel lines. No solution. And that is the graphing portion. We're also going to cover substitution today. This should be a review from, you probably graphed in, at least graphed lines in pre-algebra. Probably solved a little bit in Algebra 1, and then probably graphed some lines again in geometry. I don't know if we solved by graphing in geometry. Substitution. We have the steps or the process kind of written out here. We'll just run through this, and then hopefully it'll make more sense, and you'll remember it after we do one. We're going to get one variable by itself in one of the equations if it is not already done. Sometimes they're nice, and it'll give you x equals or y equals. Substitute what that variable is equal to in place of that variable in the second equation. Solve that second equation for the remaining variable, and then you'll get x equals a number or y equals a number, and plug that back into the original equation to solve for the other one. So it sounds pretty crazy in words. Hopefully not too bad once we get rolling here. Okay? This is one we did together in class. It was already started. We got a y equals 2x plus 1. So step number 1 is checked. We have one equation with one letter by itself. So it's called substitution because you substitute what y is equal to, this 2x plus 1, is going to go in for y in the other equation. So now in that top equation, we have 2 times 2x plus 1. I think it's good to use parentheses grouping with it. Plus that 5x that's still there equals negative 16. Okay. But Mr. Handke, this isn't better, it's worse. There's more stuff, it's longer. Yes, but look, it's all x's, which means we can solve. So we're going to distribute. And now we have 4x plus 2 plus 5x. We'll put our x's together. 4x and 5x is 9x. Okay, let's try to get x by itself. So we're going to move. We're going to subtract 2. And then we'll divide by 9. X equals negative 2. Not bad. You're also not done. No! Okay? It's not going to be much more work because you already have the hardest part done. We already have y equals 2x plus 1. Now we're going to take this, x equals negative 2, we're going to substitute it in there so we can get what y is. 2 times, not x anymore because I know what x is, it's negative 2. So we'll have negative 4 plus 1, y equals negative 3. and we'll put our finished answer, final answer here as a coordinate point. -2, -3. Ta-da! All right. Okay, after you're done looking at that, I want you to push pause and try this other one on your own. You do have a little itty-bitty baby half step. You don't have x by itself or y by itself, but it's not going to be too hard to get there from that bottom one. Doesn't matter which way you go. If you get x by itself or y by itself, you'll get the same answer at the end. Your choice. So go ahead and push pause and try that one now. Okay, welcome back. Here is what I did for that one. I got y by itself. I subtracted that x over. Then I substituted that -x plus 4 in place of y in the other equation. Now this is tricky because it's early in the school year and we got negatives being distributed. So this negative is going to go with that 2. -2 times -x is going to be a plus 2x. -2 times 4, we're going to have a -8. Put your x's together. Okay, add the 8 over. Divide by 6. And we got x equals 3. Same thing as last one. You're not done yet. You got to get what y is. But we already have this nice equation here. Negative of 3, -3, plus 4 is 1. Okay, if you went the other way, you'll probably get you should get the same answers, but in reverse. You probably got y equals 1 first, and then plugged it in and got 3 for x. Okay, we are at about 17 minutes here on the video, so we are going to jump down to the bottom two, our special cases. If you look at the two in the middle, okay, it's not always going to be super friendly like this one or even like this one. Okay, so here we are. For this one, the strategy would probably be to subtract this 2x over. Okay, here, there is no really perfect one. My thing is probably divide by as small as number as possible, so I would get this x by itself. I'd subtract the 3y and then divide everything by 2. That wouldn't be terrible. That wouldn't be too bad. Okay. Let's come down and look at this one. Okay, 2x minus 3y equals 8. Again, there's not one that's super nice, so let's take this and divide by 2. That's a pretty nice one. So we'll move this over here. 2x minus 3y equals 8. Add the 3y over. Positive 3y now, plus 8. Divide everything by 2. X equals 3/2 y plus 4. And now we're going to put that in over here. And you're going to see what happens. Four times 3/2 y plus 4 minus 6y equals 16. So we're going to distribute the 4. Kind of scary, I know, but we'll be okay. 4 times 3/2. Lots of ways to do that in your head. 4 times 3 is 12. Divide by 2 is going to be 6y. You could also do the 3/2 as 1.5, and 4 times 1.5 is going to be 6y. Or you could even do 4 divided by 2 first is times 2. 2 times 3 is 6y. So whatever works best in your brain, it's going to be 6y plus 16 minus 6y equals 16. Plus 6y minus 6y cancels, and we have 16 equals 16. Where'd the letters go? There's no letters. There's no x or y. Yikes. So if you lose all the letters or variables and you just get down to numbers and it's a true statement, 16 equals 16. That means they are the same line. That means they're the same line, they're overlapping lines. Or same line. And that means we have infinite solutions. Right? Because if they're the same line, they share all the points in common. Okay? And we're already at about 21 minutes on the video, so we're going to take the shortcut on this one. It's going to be the same thing that happens over here. All the letters cancel out. If all the letters cancel out and you get something that's not true, like 0 equals 2, not true, that means that they are parallel lines and we're going to have no solution. Okay? So if you're going through and doing your substitution, and it's going to be the same thing for elimination tomorrow, if you're going through and all the variables cancel out, and you get a true statement left, 16 equals 16, 5 equals 5, 0 equals 0, it's true, you have infinite solutions. If all the variables cancel out and there's not a true statement, 0 equals 2, 5 equals 7, okay, then there's no solutions. Alright? Okay, folks, thanks for watching. Hopefully that helps. If you need any other assistance, stop in and let me know. Good luck.